Alright.
Surprised we have a test on Wednesday. What's that?
You have a test?
No.
I think we got a quiz on Friday. I'll have to check though. Anyway, okay. Look at this little lady. She's got the Eiffel Tower here, little birdie on top. She's 100 feet away from the Eiffel Tower, and she's looking up at the birdie at 84.6 degrees. I need to find how tall the Eiffel Tower is.
Well, hold on. That's from her feet, not her face.
I know it's not. It's from the ground.
Yeah.
Because the Eiffel Tower sits on the ground,
Well,
not her face height.
but
You know what I'm saying?
the angle of her face height.
No, the angle of her toes, because it's not her toes. Anyway,
Her
alright,
eyes
so
are
what you have to decide every single time is, are you using sine, cosine, or tangent? So we gotta look, remember, from our angles point of view. From our angles point of view, how does y relate? Opposite, adjacent, or hypotenuse? Opposite. How does that 100 relate? Adjacent. So I have O and A. Am I looking at SOHCA or TOA? Which one? TOA. So I'm going to take the tan of my angle, which is 84.6. And that has to equal opposite on top. So my y on top. Adjacent on bottom. So the 100 on bottom. Remember on Friday, we learned that do stick tan of 84.6 in and round it to 4 decimal spots. 5, 7, 8, 9.
Shut up.
That wasn't nice. Equals y over 100. So how do I get y by itself? Times by 100, and we get, let's just do nearest foot. 1058, right? Okay, does this look familiar? Remember I said this is the limit, did I? There's one left. You're lucky. Also, didn't we clean out your folder on Friday? Yep. And then you decided to throw it away from Sun? Whatever. Okay, we got a damsel in distress! And we got a saver! Ladder is propped against a vertical castle wall 15 away. So 15 feet away here. The ladder is at a 60-degree angle with the ground.
That's a really long ladder. I don't think that's very realistic.
You know what? It's okay.
Especially for a
Damsels in
ladder.
distress don't need
saving.
saving. It's fine. How far up the wall is the damsel in distress? So I gotta find how far this is. That's my X.
Couldn't you just like break through into the windows of the water and call it good?
Why didn't you just go down the tower?
Okay. Math world is not realistic, okay? Anyway. Always look from your angle's point of view. How does X relate? Opposite. How does 15 relate? What am I using? SOHCA or TOA? TOA. I got the tan of what? 60, and it has to equal what over what? So, X over 15. Put the tan of 60 in your calculator.
Oh.
Is that what you said?
My calculator is in degrees, and I got radical.
Yes. You gotta hit the STD button.
Oh.
1.7321.
Perfect. How am I getting X by itself? Multiply by 15. Round to the nearest. Let's do whole number. How far up the wall? 26 feet up the wall. The second question it asks is how long the ladder needs to be. So now I gotta find the ladder. Well, the 15 is still adjacent. Should I use this X? No, I should use the Y. How does the Y relate to my angle? It's the hypotenuse. So am I using tan? No, what am I using? I got cosine of that same angle. 15 over y or y over 15? 15 over y. What is the cosine of 60? 0.5? So 0.5 equals 15 over y. Y is on the bottom. So what am I putting in my calculator? Yeah, remember we talked about flipping these? 15 divided by 0.5. I bet it's 30. 30-foot ladder. That's not crazy. You told me it was unrealistic. They make 30-foot ladders, right? They definitely do.
Yeah, for like big castle walls and stuff. Like for like a little tower. Isn't there like a staircase inside of that?
No. Have you never heard of Rapunzel?
Have you never seen
Rapunzel's
Tangled?
stupid. It's unrealistic.
Oh, that's fine. Take your headphone out though. Alright, I want to know how long is the wire if it is attached to the top of a 50-foot antenna. Draw a little antenna. Woo, this is my antenna. Tells me if antenna is 50 feet. Let's label it. It makes a 70-degree angle at the ground. Well, the wire is going to the top of it, so this is our wire. This is my antenna. I don't know if that's about right. Oh, no, that's not even. Okay, this is awful. That's fine. This angle is 70 degrees. I need to know how long the wire is. So that's my x. From my angle's point of view, how does 50 relate? How does my wire relate? So, ka or toa. So I got the sine of what? 50 over x or x over 50? 50 over x. What is the sine of 70? 9397.
I'm just gonna shut up.
You know what? The first three are always right, so that's good. The first three are right, just that last one. How do I get x by itself? Swap them. So what I'm plugging in is 50 divided by the 0.9397. Nearest tenth gets me how much? 53.2. Okay. So that's kind of what it is what we did on Friday. We're just word problems, which are everybody's favorite. Questions on word problems. Okay, now we're going to get to finding our angle measures. Alright, so you kind of already know how to set this stuff up. Okay, it's the same SOHCAHTOA deal. We're just finding angle measures now. And so, everybody knows where their sine, cosine, tangent buttons are? Okay, above them, especially if you have these, do you see how if you look at your sine, cosine, tangent in like yellow or whatever's above that, and it says like sine -1, cosine -1, tan -1? Okay, the -1 thing is what you're going to use to find angles. So to get that, you're going to hit your second button, and that's how you get the yellow or whatever your opposite color is.
Wow.
Okay. Alright. Before we do that though, we always look from our angle's point of view, right? How does 15 relate to my angle? Opposite, adjacent, or hypotenuse? Opposite. How does 24 relate? Hypotenuse. So when I set up my little equation deal, am I using sine, cosine, or tangent? Sine. So how this looks is you're going to take the sine of our angle, right? You always take sine, cosine, tangent of our angle. So sine of x equals 15 over 24, 24 over 15. 15 over 24. Okay, so this is like what we're used to doing, right? Questions on this step? Okay, to find our angle measure, all you're going to do is put the sign of that -1 thing, and then you're going to put that fraction into your calculator. If you have, how do I say this nicely? A smaller version of these, you might have to put your fraction in first and then hit that sine inverse. So if hit that second sine 15 over 24, you should get 38.7 degrees. Okay, anybody not know how to find their sine, cosine, inverse?
I was ready to read the next 4 digits, okay?
Okay, you gotta hit your button twice. So sine, and then hit it twice, then put your fraction. Okay, anybody else not know how to put this in a calculator? Okay, so you have to put the fraction in first, I think. 15, 11, 4, and then hit
I'm having the time about it.
There we go. 15. Is this your calculator?
Oh, yeah, I got 100% on that article of the week.
That's what I got.
Why don't you grab one of the big ones for me?
I almost have it in though.
So second sine.
It almost have
So
zero.
this is like that sine negative.
Yeah.
And then put your fraction.
I was
15
doing
divided by
sine
24.
of the second, so I was like,
Oh, yeah, do the
We'll just
second.
go, we'll have like 2
Okay.
minutes to
Anybody else? Calculator's not working? Alright, next one. From what my x's, that's always where we're looking at. How does the 11 relate? Hypotenuse. How does the 8 relate? Adjacent. So ka or toa? Ka. So I got the cosine of my angle x. 11 over 8 or 8 over 11? 8 over 11. So what you're putting into your calculator is that inverse cosine 8 over 11. Give me one decimal spot. 43.3.
Holy crap, I did it right this time.
And these are degrees that we are talking about. Thank you. And we're just taking notes. Okay.
And then my dad's calling the school right now, so I think that's going to be changed from a cut.
Okay. Alright, questions on number 2?
These are easy.
Number 3, how does 20 relate? Opposite, how does 37 relate? Adjacent, so ka or toa? Toa. So I'm taking the tan of my angle. 20 over 37 or 37 over 20? 20 over 37. So what am I putting in my calculator? Yep, my inverse tan
28.4.
of 20 over 37, and you got 28.4? Perfect. Just remember that these are degrees, so don't label them with like feet, inches, whatever. Okay. Couple more. How does 18 relate? Adjacent 23. So ka or toa? Ka, so the cos. 23 over 18 or 18 over 23? 18 over 23.
Wow.
What do I put in my calculator? The inverse cosine. 38.5 indeed. Just for funsies, take the regular cosine, not your inverse, so like do it wrong. Take the cosine of 18 over 23. What does it tell you?
0.9999.
Do you think we've ever had an angle of 0.9? Or 1? So some reasoning goes along with it. Alright, only one word problem over angles. It says we have a wheelchair ramp connecting the ground to a platform 4.5 feet off the ground. It is already labeled for us. This is 4.5 feet. The ramp is 11.75 feet. So this is our ramp. The ramp angle must be 25 degrees or less to be ADA compliant. Is it? So which angle am I looking at? The bottom one or the top one? I'd say 99% of the time, you're going to be on the ground level. Okay? That's probably the trickiest thing about word problems is figuring out where to label stuff. Once you have it labeled, it's not too bad. How does a 4.5 relate? How does 11.75 relate? So, ka or toa? So I'm taking the sine of my angle, which is x. What over what? 4.5 over 11.75. To find angles, we got to use our inverse. So inverse sine of 4.5 over 11.75.
I got an error.
22.5 degrees. Just put that back in so you make sure. So if it has to be 25 degrees or less to be compliant, is it compliant?
Yes.
Yeah. All right.